Hey everybody, Mr. Jacobs here, and this is board problem number 3, which of the following is a true statement. Okay, stem plots are useful for both quantitative and categorical data. Okay, remember stem plots, stem and leaf plots, the stem is the units digit, so it can't be categorical, it has to be quantitative if it's going to be the units digit. Categorical, there's no units digit. Okay, so it's not one, you guys. Stem plots are equally useful for small and very large data sets. Stem plots are great, you guys, but if you had too much of a data set, it would take too long to build, be set up for mistakes and everything. It's just too big, so it's much smaller ones, you guys. Stem plots can show symmetry, gaps, clusters, and outliers. Yes, they can show all of that, you guys. So the answer is choice. This one's the only one that's true. Is choice C. Okay, number 3 is the only one that's true. Stem plots are not useful for categorical data and are too unwildly, which is just too hard to handle, you guys. There's too many if it's too big for a large set of data. So anyways, it was number C was your answer, okay? All right, so more about shapes. This is actually an important lesson, you guys. If you guys are going to take the AP test in the spring, they want you to be able to understand your graphs and talk about them using great statistical language. So here we go. We're going to use figure 1.8 on page 26 to discuss the graph and its shape. Now, if you're in my class, I'd like you to at least write this down. You don't have to write the graph down because it's on page 26. Okay, so here it is, page 26. Let's go ahead and go over this graph right here. So it says here the figure 1.8 is the distribution of the time of the first lightning flash each day at a site in Colorado. Okay, so down here is hours after midnight. So this is 7 hours after midnight, so that'd be 7 o'clock in the morning, 8 o'clock in the morning. Here's 12 o'clock in the morning, or noon, that's noon. This would be 1, this would be 2 in the afternoon, 3 in the afternoon. So at noon right here, there's 5 hours after and 5 hours before. Okay, so let's talk about this, you guys. Okay, it looks like most of the lightning strikes are happening around noon. There's pretty much a single peak happening around noon. Whoops, I didn't mean to do that. And it looks like it tapers off on both sides evenly, so it's pretty symmetrical when it tapers off on both sides like that. Okay, what else do I want to notice on here? Let's go over here. It says the count of the first lightning flashes. Okay, over here, these are just how many lightning flashes happened on at the certain hours after midnight. So here's some characteristics, you guys. It's symmetrical on both sides, which means it's pretty even. It tapers off on both sides evenly. Okay, it's not exact, but it's even. Has a single peak at noon, so these would be all good things you'd say to your AP readers. Most of the lightning strikes happen between 11 and 1 p.m. Okay, it's nice to recognize that 12 p.m. is the most of them, you guys, but there's still a substantial amount at 11 o'clock and at 1 o'clock, you guys. So probably be better to say most of the lightning strikes that happens within that 2-hour frame right there. Alrighty, and then the graph tapers off on both sides, and then whoops, sorry, excuse me. So we're going to use figure 1.9 on page 26 to discuss the shape and the graph of this graph right here. Okay, so here it says the number of letters in the words. Okay, here it says the percent of Shakespeare's words. All right, so I guess we're looking at the whole Shakespeare play or story of Shakespeare right here. So the reason why it's in percents, you guys, it wouldn't be in numbers of words right here because there's too many words in Shakespeare. So you couldn't put the number of words in there because there would be, you know, thousands of 4-letter words in here because this is the number of letters right down here. There'd be thousands of 3-letter words. So, you know, there'd be this column right here would be much too big, or we'd have to spread it out too much. So they changed it to percents right there. Okay, so let's talk about this. It has a longer tail on the right, you guys. When it has a longer tail on the right, it's said to be skewed to the right. Okay, it does have looks like there's many more, looks like 2-letter, 3-letter, and 4-letter words than there are of the longer letter words. Okay, they're like a 12-letter word. There's not very many of 12-letter words in there. Do you think there's a 13-letter word in there? No, I wouldn't be surprised, you guys, because we're talking about percents. So it might be, you know, there might be 1 or 2 13-letter words in there, but when you're talking about all the words, it would come out to about 0%. So it would, you wouldn't even have a bar representing the 13-letter words or above that right there. Okay, so here's what we'd say. The graph has a peak, but it is definitely skewed to the right, okay? And we said this, there are very many short words, 3 and 4 letter words, and very few long words. Okay, the right tail extends out much further than the left tail, so that means it's skewed to the right. Okay, and then I shrunk it up a little bit. So also notice that the vertical scale is not the count of words, but it's the percent. The count would be too big. Okay, we talked about that. All right, so things that produce symmetrical distributions are things that happen in nature. So for example, you guys, the height of 16-year-old boys at my high school that I teach at, Del Campo High School. All right, you'd have, if we had a graph right here and say these are the shorter kids over here, here's the taller kids over here, we'd have very few kids that are, 6 feet 6 and above, and we'd have very few kids that are, 5 feet and under over here, and we'd have a bunch of kids in the middle right here. So it would create a pretty much a nice bell-shaped curve right here, because there's fewer kids over here, and then there's more that are getting taller and taller, and whatever the average is right here, that would be the most of what 16-year-old boys are right there. So typically, anything that happens in nature gives me a nice symmetrical distribution. Things that are skewed to the right are typically incomes, you guys. Say over here, this was my poor students over here. This is my really, really rich people, not students, sorry, you guys, poor people. And these are my really, really rich families over here. There's a lot more poor people and middle income people, and there's very few very, very rich people right there. So things that are skewed to the right are graphs are typical income graphs. All right, now if you're in my statistics class, and you guys probably are if you're watching this, then that would be your homework assignment that matches this. See, only 3 problems to your homework. Take care, you guys.